I'm Jonathan, and here is a presentation for the solar wind prediction model simulator. So first of all, start off with the game demo. So the first page of this is the simulation, and here there are a few different parts of it. So first of all is the data panel here, and this will show the prediction data from the prediction model, and currently this is live. So this show the current predicted severity, 1 hour ahead prediction, as well as the prediction accuracy. On the bottom left here is a data panel. This will give some information regarding solar wind. Slider on the bottom here can control the velocity of solar wind to sort of give a visualization of that in regards to Sun and Earth here. And once we click onto this button here, we can go into an Earth view. So solar wind seems like something that we really don't have any experience with, so this scene here is supposed to help better visualize that, so you can see what low intensity solar winds will do, as well as some of the potential effects of higher intensity solar winds to modern cities. There's flashing lights, lots of damage to the power grid, and during especially strong storms, even auroras will show up. So returning back to the simulation scene, the way this gets the data is from a server. This is from a Flask server that runs a prediction model, and I'll go into that next. So first of all, first part of this project was the designs, the layout of the simulation as well as UI design. Second was the data sets, which you got from web scraping, and they had to clean the data. For the model, it was feature selection, training the model, and then evaluation, and then retraining. And then for the simulation, there's the connection to the server, the live prediction, as well as the simulation effects, which were like the flashing lights, the wind particles. So part 1, design. So why do we have to worry about solar storms, even though these, we mostly never hear about these in our everyday lives? So this map down here shows regions that are susceptible to system collapse due to solar storms. As you can see in the US, there are quite a few of these, so this is something to worry about. So parts of the service, there's the prediction model, and this prediction model has 2 deep learning technologies. There's a bidirection long short-term model, as well as a time-distributed convolution neural network. And both of these models had 22 years of data for training, and they are pretty accurate for predicting the DST index. The simulation here, the goal of that was to have a user-friendly interface to broadcast prediction data, and it provides early warnings and instructions to protect against solar storms. And it will also show the potential impact of solar storms. So again, the parts here with the AI prediction engine, solar app, forecast service, the alert service, and the simulation platform. So part 2, the data sets. So the data for these models were collected from satellites on NOAA. So these 2 satellites were discovered in ACE, and these satellites were positioned at the L1 Lagrange point, so they were collected here. As for the data processing, once you get all the data, first of all, we compress all the data into a data frame. There's samples every minute, and we need to compress that into hourly data. Then for the hourly data, we get the average and standard deviation for all the different data points, and that's the data frame. And then we add in sunspot data, which is collected on the satellite as well. And then we merge those 2 data sets together, so we have a full data set, including everything. And the sunspot data gives us seasonal changes. Okay, part 3 of the model. So these 2 models, as mentioned earlier, is the Bi-LSTM and the time-distributed CNN. So as you can see on the left here, there's some of, it's a 1-week example of prediction for the DST index. So it predicts currently, and then 1 hour ahead. It's pretty accurate. On the right here, you can see the model structures for these 2 models. And the part for the simulation. So the simulation layout, again going back to the demo, we have the data panel on the top left, which displays prediction data such as the predicted storm severity, which is in the DST index, as well as prediction accuracy. There's also the info panel on the bottom left, which displays information regarding solar wind and solar storms. The Earth view here changes to the city scene, which can show the noticeable effects of solar wind on modern cities. And then the solar wind visualization, which is the slider on the bottom that can display solar wind at different speeds. For the Earth view layout, the main features is that the city lights will flash during severe storms, and then the aurora in the background also adapts to the storm severity. And then the info panel, like the scene earlier, will display additional information regarding solar wind and solar storms. So for some code examples, this is for the SolarWind prediction server here. The server is a Flask server, and the different endpoints will run the prediction model. And then the live data for the prediction model is web scraped, and then it'll get passed in and then display the data. So it's kind of like an API. And as for grabbing and displaying the data from the prediction API into Unity, here's the code that does that. It's run on coroutine, and we can have that linked to a button. Alright, that's it. Thank you.